In this example, we're going to look at finding partial derivatives through implicit differentiation. So we're given the equation yz plus x log y equals z squared, and we're being asked to find the partial of z with respect to x and the partials of z with respect to y. So we'll remember with implicit differentiation, we're going to treat z as a function of another variable. Whether it be x or whether it be y, that depends on which variable we're differentiating with respect to. But just like in our other problems, when we differentiate with respect to one of the variables, we'll treat the others like they're constants. So in this case, when I differentiate the x, I'm going to treat the y like it's a constant. When we differentiate the y, we'll treat x like it's the constant. Okay, so let's look at this particular piece, the y times z. If we're differentiating with respect to x, this y is just a constant. I need to differentiate the z, however, because we're thinking of z as a function of x. I don't know what z is explicitly, but I do know that the chain rule says that if I have a z, when I differentiate the z, I'm going to get a derivative with respect to x that pops out. Here, again, y is a constant. When we differentiate the x with respect to x, we just get a 1. So we get natural log of y. On the right-hand side, I've got z squared. Chain rule says I have to take the derivative of the outside, which is the squaring. So I get a 2z for that derivative. Z now is my inside function because I do not know what z is in terms of x. So that's where that dz dx, or the partial with respect to x, pops out again. All right, so now we've done our derivatives. We got to do a little bit of algebra cleanup, get all of our partials on one side so that we can factor out that partial derivative, then divide by that 2z minus y to get our partial with respect to x as log y over 2z minus y. Well, now let's differentiate this with respect to y versus with respect to x. Now, on that first term, I see a product of two functions of y. I see a y, and I see z, which we're thinking of as a function of y. So I've got a product, so I've got to use a product rule. Derivative of y is 1 times the z, so derivative of the first times the second, plus the first, which is y, times the derivative of the second. And much like what we had in the previous part, when I differentiate a z all by itself, I'll get a partial with respect to y in this case. In the second term now, I'm going to differentiate the y. The derivative of natural log of y is just 1 over y. And remember here, we're treating x as a constant, so there's no product rule here. Over here, we do the exact same thing like we did up here, except that now we're thinking of z as a function of y rather than x, so we're going to get a 2z and then a partial with respect to y. Here we'll gather our partials over on one side again, so we'll subtract the y times the partial with respect to y to the right-hand side. We get z plus x over y equals 2z partial with respect to y minus y times partial with respect to y. Factor out the partial derivative and then divide. And then if we want to make everything pretty, we can multiply top and bottom by y. So we get yz plus x over 2yz minus y squared.